We're back with section 17.4, Effects of Radiation on Matter. I do hope that you have completed the section reviews and gotten them back to me so I can grade them and put them in the grade book and get it all ready for fourth quarter. And, of course, if you have not done that, you do need to get that in fairly soon. I'm trying to be flexible with times, of course, during this pandemic that we have. Currently, as I'm recording, there is 25,000 individuals to the state north of me who have the coronavirus and who are in the hospital. That's kind of crazy. Of course, the state north of Pennsylvania is New York. So anyway, let's get started with 17.4 Effects of Radiation on Matter. What is ionizing radiation? Radiation can be considered ionizing if deposited energy is high enough to cause ions to occur in materials. Now, you can see there is electromagnetic ionizing radiation and non-electromagnetic. Alpha beta particles, neutrons, X-rays, and gamma rays are electromagnetic types. And you can see how some of them are very easily stopped. So if I was to emit billions of alpha particles at you, helium, it would bounce off of paper. you wouldn't be very hurt. If you got them directly onto you, you might be talking like a squirrel for a little while because of the helium, but no big. A thin layer of aluminum stops a beta particle. However, X-rays, gamma rays, neutrons, these things are these things penetrate through some very interesting things. I have a website pulled up that I will consult, nuclearconnect.org. Alpha particles stopped by air, even just a little bit of water, piece of paper, skin. Beta particles, they are stopped by just very small things. So if you had a beta particle explosion, the house beside you, the house itself would stop you from getting sick. However, gamma particles go through a lot of stuff, similar with X-rays. So if you've ever had an X-ray, I recently had a chest X-ray, they make you put on a lead apron. Why do they do that? Because lead is it shields X-rays very effectively, and so of course gamma radiation. You need a pretty massive shield. It says 6.6 feet of concrete stops gamma radiation. So if there are gamma radiation testing facilities, or you are a conspiracy theorist thinking that the government is slowly poisoning us, well, you're going to want to build your house with about 6 feet of concrete. So it's a lot of concrete. But it will protect you against just about any ionizing radiation you can think of. Anyway, ionizing radiation is bad because it makes changes in DNA, known as mutations. DNA is damaged directly and indirectly by radiation. So you can see here how this ionizing radiation splits apart genetic code. Oh no, all of the letters to genetic code are everywhere. Well, your DNA tries to piece itself together. It says, okay, let's see here. I think this was an adenine, and this was a cytosine, and guanine here, and whatever, parts of the genetic code. However, it doesn't do so perfectly. It just kind of pieces itself together as best as it knows how. Now, that's kind of okay if you have if you have ionizing radiation go through something like let's say your spinal cord. Your spinal cord doesn't reproduce itself. If your spinal cord gets severed, it's not like it can regrow. Only experimental research has even remotely done that. However, because it doesn't divide, it still acts as a spinal cord. But let's say you have ionizing radiation go through your gut, your small intestine, large intestine, etc. Those divide rapidly. And if you have a change in the DNA mutation and it divides over time, mutation get worse and worse and worse and eventually causes cancer. Which is why a lot of times cancer is found among people who are exposed to radiation, particularly people who, particularly cancers of like the colon, a very common cancer to have. Just strange mutation in one cell of the colon can cause that cancer. However, you've probably never heard of heart cancer because heart cells don't really divide. Or spinal cord cancer, not very common. Spinal developments, very rare. Now, to spot radiation, changes in radiation is very easy. It's called an ion chamber, Geiger counter, because radiation affects electrons. It's very easy to detect where electrons are strange. What to do after the detection is the concern. We can detect it very easily. Oh, wow, lots of radiation here. What to do after the detection, that's the hard part. For years, we have these units called rad and rem. Now we use the SI, Systeme Internationale units of Gray and Sievert. They're mathematically related to each other, so you can convert very easily. And your textbook likes to use the REM radiation unit. If you're exposed to between 200 and 300 REM, you have radiation sickness. It is it's everything you might expect out of like the flu, except it's not caused by the flu. It's caused by radiation sickness. 400 REMs of exposure, cancer 50% certain. And so they can tell quite easily what your exposure level has been, and 600 REM exposure you don't live from. So if exposure reaches a certain level, statistically you have received enough gamma radiation to change the DNA of your cells so much that there are so many cells in your body producing cancerous cells that it's just they don't even really treat you. You just die within 30 days of cancer. So anyway, not to be morbid or anything, but those are the harmful effects of radiation. All right, accomplished 17.4 page 302. Not too many questions, and I'll see you tomorrow for 17.5 nuclear fission and fusion.